So welcome back, guys. Today we will work with another statistical tool in ArcMap known as spatial autocorrelation on or Moran's first statistics. So first, let's take a fast glance for the theoretical basis of what this tool means. What does it do? So global Moran's one uses a z-score to assess the statistical significance of spatial autocorrelation in a dataset. So the z-score indicates how likely the observed pattern is due to random chance. It compares the observed Moran's first value to the expected value under the null hypothesis, random spatial distribution. So interpretations of these scores. So high positive z-scores indicates clustering of similar values, like example, high value areas like affluent neighborhoods are near each other. High negative z-score suggests spatial dispersion, alternative high and low values like checkboard patterns, and z-scores near zero implies no spatial autocorrelation. The pattern is random. So if a z-score is +1 is obtained, it means there is a less than 1% chance that the observed clustering is random, indicating strong autocorrelation. Conversely, minus 2.5 would suggest significant dispersion. Tools like ArcGIS and Python automatically calculate these values for easy interpretation in spatial analysis. So let's go back to our ArcMap. So again, we have the same area here. So this is a battalion, and the calls for February 15 and active stations. Here you can see active stations. Fire stations, and plus we now have this grid with 500 feet grid, 500 to 500. So why we need it? So first we will make a spatial join with calls for services and grids. So as a result, we'll get the same grid, similar grid, spatial join grids shapefile, which will have a count of how many call locations occur inside each cell. Let's go here and go to spatial joins and relates, join. So here see that there are two options: join attributes from table and join data from another layer based on spatial location. So I will choose this one, calls for services. See that they are located in different places, and we will create this grid again, which will have the number of calls for February 15 for each grid. So let's click OK. And let's wait. So it's joining. So as an output, we have join output here. See the same grid. We can close this one. It's basically the same grid, but if we open this attribute table here, see it has a count as different attributes, but it has a count. So some of them are null. We don't need null, so we will go to properties. And we will go to definition query. Let's make a query builder, count bigger than 0. So I will choose counts bigger than 0 only, and the rest will be excluded. So since this only grids have been selected, which have these calls, locations of calls, I can change the color here, make it more visually representative, red one. So these are the calls here with numbers. I can go to attribute table, see that the count number, several So most of the grids have this one call, and others have multiple calls. Might have and now I can go to spatial autocorrelation. So let's first read a little bit about the theory again. So measure spatial autocorrelation based on feature locations and attribute values. So it incorporates two things, location and attribute. Using the global Morans 1 statistics, you can access the results of this tool, including the optional report file, from the results window. If you disable the background processing, results will also be written to the progress dialog box. So I will choose this join output. Again, count. Let's generate a report here. So by the way, when we see this this grid, we can see that it displays only the cells that contain at least one call for service. But also we can look at these cells and think that we see clustering. But at the same time, we cannot see the values associated with the cells that will be used in the spatial autocorrelation calculation. So let's open, we will use cells, not join inputs. So let's open spatial autocorrelation, join outputs, count, generate report. So here we will put first 3,500 feet, which is the distance of 7 grids. So our grid is 500 feet to 500 feet. So 3,500 will be 7 grids. So clean this. So let's click OK. And we can go to results section. This is our spatial autocorrelation results. We can click to this report file. So this is the report it gives. So Moran's index is 0.02, z-score 2.5, and p-value is low, which means that given the z-score of 2.5, there is less than 1% likelihood that this clustered pattern could be the result of random chance. So see that it's highlighted as clustered. So p-value, so you can use this for your report. We can change the distance to, let's try again, to 4,000, which will be 8 grids. Let's open again. See, it slightly increased this score, almost 3, and still clustered. So let's now try to decrease the distance. Join output, count, generate report, 3,000. Results. So see that this score decreased. Moran index increase the same. So, but it's also the likelihood is 1%. It's clustered. So see that our data calls are clustered, and the spatial autocorrelation tool perfectly shows this.